Hello everyone, welcome back. Myself Samiksha and I'm teaching at Chandigarh University in Computer Science Department. So we are going to start today in this series with array operation. We'll continue with new array operations that we'll be learning. So we're going to start with a new array operation. So let me share my screen in order to give you an overview. Okay, so we are going to start with a new array operation using the programming which is C language. Okay, so the session takeaways we are going to have today is insertion into an array. How you can insert an element into an array at certain position. Now the question that comes to our mind is, what is the benefit we get as we know what is an insertion? So insertion is, kind of very helpful technique through which we can insert an element at any specific position. A data. Now let us suppose you have already entered a data for few students in an array. And later on, you decided there is a new student who took admission, in your university, and we want to add the data of that student in the existing session, or existing class, for example. So in that case, it would be quite easier for us if we know like what are the different ways in which we can add the data in the existing data. Now let us suppose there are existing number of elements in an array. So how we can add that data, like if there is another student that will get added up and an employee who will get added up, so how we can add that in the existing, at specific position or whatever is that. So we are going to learn that in today's session. Okay, so let's begin this with understanding first the concept, like how we can implement the same. Okay, so we'll be sharing a whiteboard with all to everyone. That is the whiteboard. Okay, so first of all, we need to see like how we can actually add a value inside an array. Okay, so we'll take an example of an array here. Okay, let's take an array here of some size. This is my array. Okay, so I'll first explain you the methodology and then we'll continue with the program for the same. Now this is an array, and in the array we are going to have a few values stored, and let us suppose this is the index 0. It is always going to have the index 0, then 2, 3, 4 and 5, right? So we are going to have some values into it. So let's fill it with certain number of values. For example, we are going to have 1, 9, 5, 7 and 4. Now what insertion actually says is like how you need to apply insertion. We need to enter a value. We need to enter an element in an array at suppose specific position, or let us suppose I want to insert an element at position number 1. So let us suppose k is my variable, which is actually denoting the position where actually I want to insert my element, right? Now if I talk about k here, k is 1, which is the index value. But actually, if we see from user's perspective, the actual position is second position, right? This is 1, this is 2, this is the second position. So this is basically what? This is nothing but k plus 1. Actually, if you see, it is going to be what? K plus 1. That is the second position, right? Now, or if I talk about second position, let us suppose if I'm going to enter the value of k as 2, I want to enter value at second position, right? User have given a value as 2, but with respective to your array it is going to be k minus 1. So you need to carefully observe that, because second position in array is basically 2 minus 1, which is 1. Third position in array is going to be 3 minus 1, which is 2. Fourth position in array is basically 4 minus 1, which is 3. So you need to remember that. So we'll use this one. Okay, so whatever is the position which is going to be entered by the user in array, that position is always going to be minus 1. Okay, so we are not going to use the first one but the second one. Okay, now user has specified the position that I want to enter the value at position number 2. So as per array, it is going to be k minus 1. That's what we have seen here, right? K is equals to 2 and k minus 1. Now this is also something like I want to insert at position number 1 after 1 and before 5. This is also could be mentioned in the question, or they can specify you need to enter an element after number 1 and before number 5, right? So the position is this one. So I'm just highlighting. So here, which is after 1 and before. After 1 before 5 I'm actually entering the value. So k is equals to 2. That is the second position as per me. But as per array, this is 2 minus 1, which is first index, right? Now, after that, you enter an element that you want to enter, or the number. Let us suppose I have entered the number here as, for example, 3. I want to enter a number 3 in the place of 9. Now the question comes is, after you're going to solve the question, the final output is going to be 139574. It shouldn't be like this, that when you're going to enter 3 at the position number 1 is already having a number into it, which is 9. It should not overwrite this value. Instead, it should also consider 9 and also consider this number, which is 3. So the output, the final output in this case is going to be something like this. It is going to be, output is going to be 139574. So we need to design a logic like this so that the actual value, which is the previous value which is placed at that index, shouldn't get deleted, and thus we are able to move on to the next elements, right? So what we will do is we'll apply a kind of shifting technique here that is going to shift each element one position, in the right direction. If I see from my side, it is going to be something like this. We are going to start from this value. Now let us suppose the total number of elements here are 1, 2, 3, 4, 5. So we are going to start from which position? N minus 1. So we'll apply a shifting process, and this 4 is going to be shifted to this position. Now imagine this. So we are going to start from N minus 1, and this 4 is going to be shifted to the next position. After then, what will happen? We'll move here. So what is happening? The counter which was at 4 is going to get decremented. We will start from, let us suppose this is my loop, and it is going to start from, this is my starting point. We are going to start from this point, and there is going to be a counter that is going to be decremented. Let us suppose this is my I and this is my counter. This is going to be decremented every time. It is going to start from which position? N minus 1. After then it will get decrement, will reach to position number 3. And again, what we will do is the third value is going to be shifted to the next higher index value. So basically what is happening here is the counter is getting decremented, and every time a of I value, every time a of ith value is getting shifted to the next higher index value. Like this is what actually happening, right? So every time we are shifting this element here, and 7 is going to be the part here. After then we are going to erase this part here, and this has been erased. After then what will happen? Again, the counter will be decremented from third to 2. Again, it is going to be I minus minus, and a shifting is going to be applied, and second index value is going to be shifted to the next higher index value, that is 3. That is a of I plus 1 is equals to a of I. So 5 is going to be a part of the third index now, and we are going to erase 5 here. So this is going to be erased here. After then we have here 9, and in the similar way 9 is going to be shifted to the next higher index, and this counter is going to reach here, and now this space is empty. We can say here this. Now this is a blank space. Now you can add the element here, whatever is the number. So the number here that you want to enter is 3. So I'm going to enter number 3 successfully here. And we need to stop at this point. So this means you're going to start from N minus 1, which is this position. And you need to start from here to, you need to move till which point? Till the time you didn't reach the value, which is k minus 1. Because this one is the second position where we wanted to insert. That is as per the user, it's second. But if we see as per a programmer, this position is nothing, but it is going to be k minus 1, which is nothing but 2 minus 1 is 1 as per the current example. So we need to start from N minus 1, we'll move to k minus 1. Every time our counter is going to be decremented, and we are going to shift each and every element to the next higher index value. And thus we are going to make this space free for the new element to get added up. We need to empty that space in order to get the new element added up to that position. So that's quite easier, right? So let's see this through a program, that if I need to convert it into a program, how I would be doing that. So let me share my compiler screen with all of you, and then we'll see like how we can convert it into a program. So that was the previous one we did. So we need few things in this program. We don't need beginning and end and mid pointer. We need temp, and we need key also, like the position actually where you want to insert. We need an array obviously, and enter the number you want to search. Now instead of search, I'll write here the number you want to add. It could be any position. That also will take from user, and I'm going to delete this part, the one that we were doing. Okay, so what we are doing here is enter number you want to add. So I have entered the value that I want to add. After then, I'll ask user in which position actually you want to add. Enter the position also. You can specify. Enter the position also. So now here you are going to enter the position as scanf, and we are going to have scanf person D, and here we are going to have ampersand and k, right? Now this k could be 2, this could be 3, this could be 4, but with respective to the image, the array, it is going to be k minus 1, because an array, it always starts from 0. So position is going to be always 1 less than whatever user is going to specify here, right? After then, now you're going to apply the logic that is going to be for loop, and in the for loop, you remember that we are going to start from n minus 1, that is the last position, till the time we didn't reach to k minus 1, the actual position where you want to insert, and it is going to be I minus minus. We are going to decrement the counter every time we are going to move in the backward direction, right? So I is equals to n minus 1 till the time it is greater than equal to k minus 1 and I minus minus. Now, what is the shifting logic that I have told you? The shifting logic is going to work like this, that A of, why I'm writing AI plus 1 first is because the movement always goes from this side to this side. So we need to express it this way when writing a code. Now, when we are specifying it, so it is shifting the value which is at third index to fourth index, the value which is at second index to third index, the value which is at first index to second index. So it is shifting like this. The lower index is being getting shifted to the next higher index value. Okay. So after we are done with the shifting, we'll come out of this loop, and at a of k minus 1, when we'll reach that position, we are going to insert that value here. The total count of elements or numbers, which was previously n, now is going to be n plus 1, because after insertion there is going to be an increment of 1. The total number of count now is going to be incremented by 1 after after a one successful insertion operation. Now, after this, let's add one more loop in order to verify that whether the insertion has been successfully done or not. So here I'm going to have a printf, and in this printf, I'm going to have it like this. Array elements. So array elements after, we can say insertion. Array elements after insertion, and this is going to be like a loop, and my loop is going to be started from 0 less than n and I plus plus me, because now this n is updated after the insertion of one element that we have already updated here. And we are going to have printf here to display the final set of elements, and this is going to be printf person d. Let's put some space here, and a of I. Done. So yeah, so this is going to display my array elements after this insertion, and I guess we are done with the int main. So we need to close the bracket here. We are done with operations. Okay. So let's run the code in order to see that whether our element is getting inserted accurately at correct position or not. Okay. So let's see here. Let's move here. Okay. So how many numbers you want to enter? Let's enter a few values here. Let's enter values here as 5. Enter numbers into an array. So let us suppose we are entering numbers into array as 2, 4, 7, 5, and 8. Okay, so we have 5, 2, 4, 7, 5, and 8. And the number you want to add. Now let us suppose I want to add a number here as 3. And the position also. So I'm adding the position of this number as, for example, second, which is going to be basically the fourth value. I mean, the index where 4 number is, which is the 0, 1, means one index value, which is the second position according to me. So it should be like 2, 3, 4, 7, 5. It should be the answer. So yeah, now if you see the output here closely, so this is going to be, previously it was 2, 4, 7, 5, 8. I entered the position, I entered the number as 3, I entered the position as 2, which is, as per me, 2 is this, but as per my array it is going to be one index, right? The logic was working here. So after 2 and before 7, after 2, sorry, and before 7, which will basically become before 4, because 4 is not going to be deleted, it is going to be ultimately shifted to the next higher index value, right? Because we don't have to actually override, it's addition without deleting the previous set of elements that already exist into your array, right? So this is going to become 2, 3, 4, 7, 5, and 8. Right? So I hope the logic is clear to you, because it's quite easier. You just need to take care of the loop, like from where you need to move. You need to move from the last position till the position where you actually want to enter. You need to keep on decrementing the counter, because you're moving in a backward direction from the last index value. And every time you are, adding e of I into e of I plus 1, right? And in a of k minus 1, the temp means the number that you're going to enter is going to be entered at that position k minus 1, and the total count is going to be incremented by 1, right? The total count of the loop is going to be incremented by 1. So that's how we are going to solve the insertion. So insertion, uh, could be done at any point, whatever you feel like. It's like, if you want to perform insertion at a specific index or a value, you can perform. If you want to perform an insertion after a specific value, you can do. After a specific element, before a specific element, you can do. And thus, taking it as a summary, the crux of the matter says that insertion makes it quite easier, to add the element at existing position or existing data, whatever we have. So later on, at any point of time, if we want to add a new element into an array, we want to add the data into an existing data, it becomes quite easier for us to do that. Okay, so I think this is clear to all of you. So let's start with some few questions. Answering the few questions about today's topic is, can I make insertion and deletion at any position in an array? So yeah, it is also asking about deletion. The same like insertion, we have a methodology deletion, because insertion and deletion, they works both ways. We are going to cover deletion in a short span of time also. So yeah, we can do both of these at any position in an array, before an element, after an element, at any random position. You just need to specify and ask user that which element you want to enter, and what is the position that you are considering to enter your element into, right? So we can make insertion and deletion at any position in an array. Okay. So next question, element in an array are exist, right? So you have 4 options. So this is MCQ. So when you're taking elements in an array, there are certain orders in which you can access those elements from an array. Like for example, we have here as randomly. Can you access the elements randomly? Can you access the elements sequentially? Can you access the element exponentially or logarithmically? So what you are going to say in this context, that how you're going to access the elements of an array. Think about it, how you can access the element of an array. I'll give you 1 minute for the same. Think of it, how we can access the elements of an array. Okay, so when we are accessing an element from an array, we have different options. But when we categorize that into one word, that is going to be randomly accessed. Absolutely correct, right? So whenever we are going to access the elements from an array, it is always called as random access. You can go to any position and you can access the value from there. You can add a value there. You can delete a value from there. So you know all the methodologies. So you can perform operations with taking the specific index value of an array. Right. So I hope you are clear with what we have done today. That's all for today. So we'll see you in the next, lecture series where we are going to cover about the topic, which is going to be deletion operation in an array. Thank you so much.